linear approximations, and differentials. Our objectives is to approximate function values using the equation of a tangent line at x equals a. And we could approximate such values near a. The way we're going to do this is actually approximate the function with a linear function. On top of that, we're going to introduce the language of differentials to prepare you for the learning of antiderivatives. We'll begin with a definition. Suppose f is differentiable on an interval containing a. Remember, a is on the x-axis and a is an x value. The linear approximation to f at a is this linear function. And if you look closely, this is essentially the equation of the tangent line for point of tangency a comma f of a. More importantly, f of x is approximately this linear function for x values near a. Why don't we put this definition into good use? Use linear approximation to approximate the natural log of 1 5/100. Notice the definition requires a function. So that is what we're going to do first. We're going to define or state our function. Let's let f of x equal the natural log of x. And our a value to be 1. We know f of x is approximately the linear approximation, or the linear function, for x values near a equals 1. If you need to, take advantage of additional paper or additional space and write out the derivative of that function. Notice it's simply 1 over x for x greater than 0. And if you evaluate this derivative at a, you get the slope of the tangent line. Now, one good way to learn vocabulary is simply write the definition. So I'm going to go ahead and write the definition of the linear approximation for the function f of x. We're ready to substitute. And notice our linear approximation is indeed the linear function x minus 1. One last procedure. Our goal is to actually find such an approximation for the natural log of 1 5/100. This is approximately the linear approximation evaluated at 1 5/100. Our conclusion is that the natural log of 1 5/100 is approximately, you can see it, it's approximately 5/100. This would be a good time to pause the video and you could attempt example 2. See if you could define the function and choose an a value so that you could actually approximate the function that you define. This would be a good chance to pause the video and attempt this problem yourself. Now, if you want to check your answer, unpause the video and let the video run and see if your writing compares with what you're supposed to get. Now what is the cube root of 1 million? Cube root of 1 million is simply going to be 100. Once you do that very important scratch work off to the side, we're ready to find our linear function. The cube root of 1000 is simply going to be 10, but I'll write it for now. One last procedure. We want to approximate the cube root of 1001. And using that line above, this is probably easier to use. Finally, we get our approximation. The cube root of 1001 is approximately 3001 over 300. Notice there's actually 3 separate procedures being done. You could even say there's a 4th one if you consider the side work here. So make sure you are staying organized, be able to present your linear approximation, and notice how powerful that equation of the tangent line really is.